Okay, so this is my
Yes.
formula. Actually, with the help of that formula, we are using in Gauss-Seidel iteration also and Gauss-Jacobi iteration. What the formula of iteration I am writing, you just try to remember here. I am using a loop to do lots of iteration, and that loop will be terminated with the help of on the basis of question what is it will be asking to you. Okay, suppose you have to write the answer up to 2 decimal place or 3 decimal place. In 2 consecutive iteration, you will see the results of x values and y values and z values are matching up to 2 decimal match. So you may stop. In that way, you have to stop. So I am writing this just step by step iteration continuing. So suppose I am using a for loop I equals to 0, I less than, I'm doing lots of iteration here is also I plus plus. So what I'm doing to get an x0, y0 and z0 are the initial value that is you have to consider, or in the question it will be given to you. Suppose you will consider that is maybe 0 0 0, you just consider. Okay. Assume or in the question it will be given. So with the help of x0, y0, 0, all value will be used in the right hand side. So I0 means suppose to get x1, xi plus 1, to get x1 you need y0 and z0. But in Gauss-Seidel method, to get y1, what x is updated here, that updated value I will not use in this iteration. I will use in this iteration simply the initial value. So still it is I and this is I. And in this place also I, this place also I, and you will get left hand side I plus 1. Only that is the difference. Means initial value will be used, all value will be used in first iteration. After getting first iterated value, all value will be used in right hand side to get second iterated. After getting second iteration values, use in right hand side to get third iteration. In that way, step by step it will proceed. Means all value will be used. Means whatever the iterated value will you are getting, that will be used in next iteration, not immediately next calculation. Okay, within the iteration. Are you getting my point? What is the difference?
Yes, sir.
In Gauss-Seidel method, you just see, are you seeing this value x? X is updated, so I am using there xi plus 1, but z is not updated, so zi simply. But to get zi plus 1, x updated, y updated, so we are using there x in this place, xi plus 1, in this place yi plus 1. It was the algorithm for the Gauss-Seidel iteration. Now in Gauss-Jacobi method, this is the algorithm. So that much difference. Computational time taking, it will take in Gauss-Seidel iteration little less, because its rate of accuracy to get the result is little high. Okay, because whatever the updated value you are getting in that method, that values immediately you are using in the next calculation, that may be within the iteration, that doesn't matter. But here what you are doing, whatever the value you are considering, that is simply used to get the next iterated value calculation. But here you just see here x is updated, but that updated value I am not using here. Okay, only that is the difference. So I told you little difference is done nicely. That idea you just keep in mind. Besides that, condition of convergence, everything is okay for both techniques. Condition of convergence, if it is not, if possibility is there for rearrangement, that partial pivoting you just do to satisfy that sufficient condition. After that you just try to solve. So both the techniques having the conditions of convergence or any other things, whatever we discuss theoretical importance is same for both techniques, but in Gauss-Seidel iteration, updated value should be used in immediately next calculation. That may be within the iteration, but in case of Gauss-Jacobi iteration, values will be used simply in the next iteration. Only that is the difference. Let's try to see this solution, what it will happen. So can you able to, you do have calculator? With the help of calculator, you just quickly solve and tell me the answer. With the help of Gauss-Jacobi iteration, we are going to solve this. Okay. Same equation we have solved here. Okay. And suppose this question is solve this up to 2 or 3 decimal place, that will be given to you in question using initial condition, or sometimes initial condition is not given to you. Then I told you by default it will consider 0, 0, 0. That idea also I told you in last class. So suppose initial value is not given to you, so you may consider initial value x0, y0, z0. What will be the first iteration? That formula you just try to remember for the iteration steps. I am writing the first iterative value here. In first iteration, you will get x1, y1, z1. That x, y, and z, how I will get? 1 by 20. That is x1, y1, z1. These are the values of x, y, z in first iteration. Okay. Follow? What was the formula? (30 minus 2 y0 minus z0). Okay. What is the y1? 1 by 40, 75 plus x0 plus 3z0. And to get z1, 1 by 10, 30 minus 12, 0 plus y0. And x0, y0, it is not given to you, suppose in the question. So by default, you just consider x0, y0, z0 is suppose initial value of the x. That is we have considered. Okay. If it is not given to you in the question. So what will be this value? Numerical. Y0, 0, z0, 0. So x1 will be 30 by 20. What is this value? Just tell me. This is 0. Okay. 30 by 20. Quickly tell me. With the help of calculator, you just quickly tell me the answer. 30 by 20.
1.5.
Okay, in first iteration to get y1, you are using x0 and z0. x0, 0, z0, 0. So that will be 75 by 40. Follow? 1 point. Quickly, you just do the calculation. 8175. And actually, this is x0, 0, y0, 0. So 30 by 10. What is the 30 by 10? 30 by 10 means 3.
3.
That is your first iterated value with the help of initial value. What is the difference? My target is to clear you the difference between that two techniques. That problem we have solved in Gauss-Seidel iteration. Now we are going to solve in Gauss-Jacobi iteration. And what is the difference in that two techniques? That is, it should, that theory must be clear to you. In Gauss-Seidel iteration, we are using their x1. In this place x1, in this place x1 and y1, because that value are updated. But we are not using here updated value. Simply initial value in first iteration to get x1, y1, z1. These are the first iterated value. I will use all that iterated value in next iteration. Only that is the difference. Is it clear?
Yes, sir.
So quickly you just tell me what will be the second iteration scheme. To get x2, y2, z2, your formula scheme, I will use always from the system of equation what is the recurrence relation or formula we have built. From the system of equation we have built this formula, no? So that formula structure always I will use, means this formula structure. So to get x2, y2, z2, same formula structure I will use, but that subscript will be changed to y1 minus z1, and y2 will be 1 by 40, 75 plus x1 plus 3z1, and z2 will be 1 by 10, 30 minus 2x1 plus y1. This right hand side x1, y1, z1, all value already you have calculated in this step. These values you have to use. So can you able to calculate this? 1 by 20. Quickly you just tell me the answer. So 30 minus 2 into y1 means 1875 minus z1. What is z1? Z1 is 3.
3.
So after doing this, what is the value you will get? Quickly you just try to tell me the answer. Put these values and
Sir,
tell me
1.1625.
1.1625. Okay, this will be 1 by 40, 75 plus x1. What is x1? 1.5. This is x1. Okay, plus 3 z1. 3 into z1 is 3. Okay, so 9 plus 76.5 divided by 40.
Sir, 2.1375.
1375. Very good. That is also you just tell me in this process 1 by 10. That is everybody you just do calculator with the help of calculator, such that technique will be clear to you. I think if you will do now, you don't have to practice a lot of the things about these techniques. Okay, it will be in your mind for a long time. Okay, you just do that practice. Okay, 30 minus 2x1. 2 into x1 means 1.5. That is already you have calculated, plus y1 means 1.875. It
Sir,
will be
2.8875.
8.875. Very good. Don't do the wrong calculation. Nicely, you just do these calculations like that. You will get matching result quickly. The third iteration. X3, Y3, Z3. To get that things, I will use that second iterated value in the right hand side, and my formula scheme will be the same. Simply subscript will be the 2, second iterated value. Okay, 2y1 minus z1. Actually this is 2. Is it clear?
Yes, sir.
By 40, 70 plus x2 plus 3z1. Sorry, z2. And z3 will be 1 by 10. 30 minus 2x1 x2 plus y2. Actually, previous line, by watching the previous line, step by step, you just increase the subscripts and iteration values. Okay. Formula scheme will be the same because this is built from the system of equation. Okay. So here x2, y2, z2 values you will get, or you will use from here. Try to write all that things from up to 4 decimal places. Okay. Because in the question sometimes it will be asked to 3 decimal place. So if it will be asked to 3 decimal place, write down the every values up to 4 decimal places. And if it is asked to you 2 decimal place, then every value you just try to write up to 3 decimal place, such that at the last step you may bind or round off the values. And in 2 consecutive iteration, you will see and watch what it will happen. Okay. So tell me the values of this. That x2,
1 by
y2.
20.
That x2, y2, z2 you have to take from these places. Okay, x2, y2, z2. Okay. Third iteration is coming
1.141875.
1.75. I am writing 4 decimal place.
Yes, sir.
Now, this is 75 plus x2 plus 3z2. That x2 and z2 you will take from this value and this value. Divide by 40. Don't do the wrong calculation. Okay.
2.1206.
2.1206.
06.
30 minus 2x2 plus y2 by 10 means whatever this value will be, you are getting 1 point, you are dividing by 10 decimal place, you just move forward the decimal places one again left side.
So 2.9812.
192. In understanding, anybody you do have a still doubt, you may ask, because in these two techniques there is nothing too much. Simply these things will be in your mind. Only numerical problem solving criteria is the important. In this way, for the theory exam, you have to solve the problems. And when you stop, and that idea, you just nicely keep that things in mind, such that it will remember forever. Fourth iteration. You just are you seeing this little bit result is matching? Still not matching actually. Try to do one another iteration. Try to do one another iteration. This is 1.6, 1.4, 2.12, 2.13, 2.8. Almost matching, but still I'm not getting exactly decimal places matching. So calculate x4, y4, z4. This will be 1 by 2, 20, 30 minus 2y3 minus z3. This will be 1 by 40, 75 plus x3 plus z3, and this will be 1 by 10, 30 minus 2 x3 plus y3. In this case also use these values and tell me these iterated values.
Sir, 1.1388.
1.1388. Okay. And this is 1.1. Okay, no problem. It is matching. 2 decimal you may be able to write from here also. 2.12 or
Sir, 2.1271.
2.1271, no problem. This value also just try to
Yes, sir.
tell. 2. I think 9 will come. 2.9, 2.98. Maybe 2 decimal will match there, no problem.
So that value is coming 2.61.
2.6.
Sir, I think it's wrong, sir. Let me do it again, sir.
Anybody else you are not doing? You do have lots of students. You just verify whatever the results we are writing. You just verify. It's somewhere we are doing wrong calculation such that it will be clear. And it's this is somebody, one student is telling, that means it is not that simply he is doing. This work is for everybody of you. You just verify this and do that practice. Okay.
Sir, it is coming as 2.928.
9,
Yes,
2,
sir.
8.
928.
28.
9, 2, 8. 2, 8. You just see in the previous iteration. Okay. Are you seeing this? It is not. Still do little more calculation about this. Okay.
Sir, it is coming 2.9837.
I think this is the actually why I am getting this idea that may be wrong. Are you seeing this? Actually, this place, if I will round up this place up to 2 decimal, it will be 1.14. This will be, if I will round up to 2 decimal, it will be 1.12, and this will be 2.98. You just see these two values are almost match along with the previous.
Yes.
1.
So it is coming 2.9838.
Let's verify this. 1.14, and this is 2. Can we able to write? If I will simply not round up, simply truncate the remaining decimal place, still I may able to write these things up to 2 decimal like that. Okay. At least 2 decimal is match. Okay. So here, if in x and y variables are matching up to 2 decimal places, so obviously z calculation is the last calculation. So obviously in this case also it will be matched up to 2 decimal. So 2.9292 you are telling means obviously you are doing wrong things. And that
Yes,
idea.
sir. 98.
Okay. So
It is coming 2.98.
9,
Yes.
8, 98 something, 9837.
8.
Okay, that is approximately what? That is approximately 2.9. So with the help of these two iterations, if the question is asked to you, write down the answer up to 4 decimal place, sorry, 2 decimal place, you may be able to write the approximate answer is x value is 1.14, y is 2.12, z is 2.98, isn't it?
Yes, sir.
If the question is asked to you, write down the answer up to 3 decimal place, then again one more step you have to do calculation. Okay, again one more step. So with the help of in the same way, quickly you just do this calculation for the 5th iteration. Which type of values are coming, it will be more clear to you. So x5, y5 and z5. With the help of this recurrence relation, 30 minus 2 y4 minus z4, 1 by 20, sorry, 1 by 40, 75 plus x4 plus 3z4, and this is 1 by 10 30. You just use this 4 decimal, not round up value. Okay. You just use this 4 decimal place because I need
Sir,
the answer up to 3 decimal places. So you just use this value, not updated value. Sorry, not in the blue color what I have written round up value, that value not. Because I need the answer up to 3 decimal place. Sorry, this is 4. Tell me this value.
sir, 1.139, first one.
Okay, 1.139.
Yes, sir.
139.
Yes,
Sure.
sir.
Okay. This
Yes,
is
sir.
next value.
Sir, sir, that is coming 2.127 only.
2.127. This is which value you are using? That round up values or this 4 decimal places value?
So 4 decimal.
Okay, that is I told you. Actually, you need the answer means 3 decimal. Write down the answer up to 4 decimal places at least. Okay, no problem. Tell me the last value. Obviously, it will match or give you up to 3 decimal place matching. Nine eight. After that, which value is coming? Just a minute.
2.984.
4. Okay,
Yes.
984, no problem. You just see and watch. Now, what I am doing, if I will round up this value up to 3 decimal place, it will be 1.139, isn't it?
Yes,
From
sir.
here. If I will round up this value or not round up, simply truncate up to 3 decimal place, you just see this is 1.27. 2.127. This is 2.127. And this is 2.9837. Means if I will round up this will be 2.984. So result up to 3 decimal place, you may write these values. Okay. And what was in Gauss-Seidel iteration method? 1.13, 2.12, 2.984. In Gauss-Seidel iteration method, same things we have done. X.139 was there up to 3 decimal place, or if I will round up, it is 1.14. In Gauss-Seidel methods, in last class we have done. This is 2.127 we got up to 3 decimal. 2.12 is also we have got, and Z is 2.984. That is I got today here. We just see 2.984. Same system we have considered, and in this case, no initial condition is given to you. By considering 0, 0, 0, after doing some steps, we are getting the matching results. Since sufficient condition is satisfied, means pivots elements are the greater than the remaining sum of the coefficients. That sum and that verification you have to do for the absolute elements. So both technique is applicable or its condition is same. Okay, but Gauss-Seidel method is more advanced, or it will give you less computational error or less computational time, because in Gauss-Seidel iteration immediately the updated value you are using the next calculation, so quickly you will get the result. That possibility is there in Gauss-Seidel iteration. Okay, and number of iteration will take less in compared to Gauss-Jordan sorry, Gauss-Jacobi iteration. So name is confusing actually. Try to remember how many things we have learned. At starting Gauss in this module 5 techniques you have learned that previously that 3 techniques are direct techniques. That in direct techniques we learned Gauss elimination method, Gauss-Jordan elimination method, and LU decomposition or factorization method. That 3 techniques are direct methods. In iteration methods, we learn 2 methods. Everywhere Gauss name is there. In this case, Gauss-Seidel iteration and Gauss-Jacobi iteration. That 5 things in terms of name, you should be aware which technique is what in that way. Don't be confused, okay? Just a minute. Hello. पार्ट्स दीजिए ना 2 नंबर गैप में दीजिए. Is it clear, students?
Yes, sir.
Then tell me, any other query you do have? Otherwise, actually, I told you in last class, this is the sufficient condition. Why not telling this is the necessary condition? That point, that is the scientific point actually. Can you able to give some counter example? Means that sufficient condition is not converging. Besides that also you are using Gauss-Seidel iteration or Gauss-Jacobi iteration and you are getting the matching result, means solution. Although this conditions is not satisfied. Can you able to get some systems? Can you able to pick up some system or give some example for which system these 2 techniques is applicable, but this condition is not satisfied? So that is your actually assignment. Convergence is not satisfying, and some examples, but both techniques are giving matching results. After some iterations. Oh, actually, same. Why the condition convergence not sufficient. You just, that is your work. Actually, you just find some examples such that without satisfying that conditions, this method is giving you the matching result after doing some iterations, and you can able to write the approximate solution after doing some iteration. But that condition of convergence is not satisfying. Actually, this is not actually questions. Can you able to get? At least you just find out 2 by 2 equation. Actually, in that equation quickly you may verify. Any example you may give. Okay, you find that examples. Okay. Or any other query you do have? In module 2, one another important things is there. With the help of actually for a square matrix, you are finding the eigenvalue and eigenvector. That physical interpretation I am not telling you too much, but with the help of numerical techniques also we will get the eigenvalue and eigenvector. That process I will tell you in next class. Okay. Is there any query?
No, sir.
Okay, very good. So we are ending the meeting.
Okay, sir. Thank you, sir.
Thank you, sir.
You are welcome.
Thank you, sir. Sir, what about